So suppose your complexity is coming out to be like 2n square plus 5n plus 2. So how will you tell that exactly what is the rate of growth of this equation? You just find out what is the highest order term of this equation. The highest order term is this one. So you don't take the lower order terms. No need to take the lower order terms. And even in this highest order term, no need to take the coefficient part. Okay, so you can say what is the complexity? What is the rate of growth of your complexity? That is your n square. That is quadratic like. Okay, so again, all these things will get repeated. So right now, this is important. Like yesterday, again, some students were having doubt that what is the meaning of the rate of growth. So again, these things are being repeated. What's the meaning of rate of growth? Rate of growth is the rate at which something is growing. So what we want to find out, the rate at which something is growing, we need to find out the complexity. So this side, suppose I'm taking the complexity, and this side I'm taking n. So if your graph is coming out to be something like this, you will say the rate of growth class is linear. That means your complexity is increasing in the linear manner. But suppose if whenever you're drawing a graph and it is coming out to be like this, okay, suppose if your complexity is something x squared by 8, it will be something like this. So you will say it is exponential. Or the complexity is increasing, it is increasing in the exponential manner. So that is the rate of growth. And if the complexity is coming out to be like this, you will say that it is logarithmic. Okay, so if I'm just taking these three cases, what do you think? Which algorithm is having the least complexity? Exponential one, linear one, or logarithmic one? Yes, you can write down in chat box. This side on y-axis, I'm having the complexity. On x-axis, I'm having n. So what I'm asking you, I had just drawn three lines. One is exponential, second one is linear, and the third one is this one, logarithmic. So I'm asking you, out of these three, which one is having the least complexity? Yes, Nitish, it's right. Okay, Bhupali, Manav, okay, Vishaka, right. So Amandeep, okay, fine, right. So you can see over here that this line is having the least complexity, because as you're increasing the value of n, complexity is increasing. The maximum complexity is only this much. Okay, so logarithmic complexity is the least one, then linear one, and then is exponential one. So you can see just like this, there are many other classes into which you can place your algorithm. Your algorithm may have the logarithmic complexity, it may have linear, or it may have the exponential complexity. So what are those different classes? So I will tell you about those then. And this is very important. So I have made one table, and this thing is, again, I'm saying it's very important whenever someone is asking you a question from this unit in Viva, mostly that question will be related to this table, like you can see. Okay. So here I have written some names. I have written log n, then n log n, then n square, n cube, 2 raised to power n. Then here it can be, suppose I'm writing in table, it's not written, but it would be n factorial. Okay. So whenever we will be finding the complexity of our algorithms, it would be one of these. The algorithm complexity may be log n, it may be n, it can be n log n, or n square, or n cube. Okay, it can be anything now, n raised to power 4, suppose. Then you can have the exponential, 2 raised to power n, then n factorial. Okay. Now I want to check that out of all these classes, which rate of growth class is having the minimum complexity or the maximum complexity, or if someone is asking you that out of these two, which one is having the more complexity or which one is having less, from this table you can find out that. Okay, so what is this? Here I have taken the value of n. N means the number of items. Okay, suppose if the number of item is 1, the complexity of any algorithm that is having the complexity, suppose in the order of log n, it would be 0, n1 would be 1, and log n again 0. Okay, so there is no much difference if the value of n is 1. When n is 2, you can see it is, if any algorithm is having the complexity log n, you can say the complexity of that is almost 1, it is almost 2, 2, 4, 8, 4. Then again, not much difference between these classes. You take value of n as 10. You can see over here, to log n hai, uski complexity is coming out to be 3.3. Here it is 10. Here it is 33. Agar n square complexity hai, so it is 100. N cube hai, to 1000. And 2 raised to power n, obviously 2 raised to power 10 is what? 1024. So you can compare. That means if one algorithm is having the complexity log n, and other one is having the complexity 2 raised to power n, so you can see for n is equal to 10, there is very much difference, 3.3 and 1024. Obviously, there is a difference. But you check for other values. Suppose I'm taking n is equal to 20. For log n, value is 4.3. Here it is 20, increasing 86, 400, 8000. And here you can see this thing. This value is very large. Okay, fine. Now you take the value of n as 60. Obviously, the value of n 60 is actually very low. 60 means just 60 elements. Suppose I want to sort or I want to search, like for a particular student from your class, even in your class, you are having 80 plus students. Okay, so 60 is very less. But in case of 60 also, agar kisi algorithm ki complexity log n hai, so that means it is performing around 6 operations. Agar n hai, to it is performing around 60. But agar complexity 2 raised to power n hai, to you can't count how many operations you need to perform. Okay, so you can see this difference. So over here, I'm writing something now that as you will move from log n to n factorial, even if you will take n factorial, that would be very large value. Complexity is increasing. Complexity is increasing. So this table you need to remember. You don't need to remember these values. These were just for your understanding. You need to remember this thing in this order only. Log n is having the least complexity, then n log n, then n square, n cube, 2 raised to power n, and n factorial. Okay. So if someone is asking you that, suppose you have been given two algorithms, A and B, and A is having the complexity n log n, and B is having the complexity suppose n, then out of these two, which one is better? Which one is better means obviously for us, which algorithm would be better? That is having the least time complexity. So out of these two, which one is having the least? This one. So you can say B is better as compared to A, because n is having the lesser complexity as compared to n log n. Okay. Now, here I'm writing something. Okay, I'm leaving this thing. I will tell you what's the meaning of this big O of 1. So if what is the meaning of big O, even that would be cleared in next topic. Okay, suppose if any algorithm is having the complexity log n, you can say that is having the logarithmic time complexity. Okay, so these words you can use now. Logarithmic. If it is n, you can say that is having the linear complexity. If it is n log n, linearithmic, but this word is not used much. Okay, but if you want, you can use this one. Okay, next one is like if a complexity is n square, you can say complexity is quadratic. If it is n cube, you can say it is cubic. If it is something 2 raised to power n or 3 raised to power n, I have written k raised to power n, you can say the time complexity is exponential. And even if it is factorial form में आ रही है, तो that is also exponential. Is it clear? Fine. So even you can use what I was telling you, that these names. Now, this thing is very important, although again, I will be repeating these things. I have written here, okay, do one thing, I will take this later on because you don't know the meaning of big O. So I will take this thing later on, okay? Okay. So right now, if I'm asking you that, suppose any algorithm is getting this complexity, suppose I'm finding the exact number of operations that are being performed by any algorithm, and it is coming out to be this equation, that 2n raised to power 3, that is 2n cube plus 5n plus 3. And right now, if I will ask you what is the meaning of this, or what is the complexity of this algorithm, now you know that you don't need to take the lower order terms, you don't need to take the coefficient of the highest order term. You will say that the complexity is n cube. Okay, till now I have told you this thing, but this is wrong. Okay, never say that the complexity is n cube, because when I'm saying n cube, then if n is 10, you will say 10 raised to power 3. Complexity is 10 raised to power 3. If n is 1000, it should be 1000 raised to power 3. That means exact number of operations would be 10 raised to power 3 or 1000 raised to power 3. No, it is not like this. So whenever we need to represent a complexity, there are some notations, there are some ways to represent that complexity. Your complexity can't be exact n raised to power 3. It can't be exact n or n square or log n or n log n. Okay, so there are some ways to represent these complexities, and this topic is really very important one. So what are those notations? Those are called your asymptotic notations. Okay, so there are several types of asymptotic notations that are used to describe the running time or the time complexity of an algorithm. So what I will be taking, first one is big O, then big omega is there. Third one is big theta. Okay, there are 3 ways to represent the complexity of any algorithm. Again, I'm repeating big O, big omega, and big theta. Even you are having small o, small omega, and small theta, but I won't be taking those things. Out of even these 3, whenever you are finding the complexity of any algorithm, suppose if you're using any website or if you're referring any book, you will see that the mostly complexity is written in terms of big O. Okay, so all these things I will be taking now. Fine. Okay, first thing is now big O notation or big O. Mostly students know this thing, that whenever I will ask them what is the complexity of binary search or linear search, they know the answer. They will tell me that it is big O of n or big O of log n or big O of n square, something like that. But whenever we ask that what's the meaning of big O, usually they don't know this thing. Okay, so first I will tell you the meaning of the big O in simple terms. Then suppose if in exam it is coming that what's the meaning of big O, or write down something, explain this big O notation, then obviously you need to write down these definition formally. Then I will take that thing. Okay, but actually what's the meaning of big O now? So whenever you are representing the complexity of any algorithm in terms of big O, then remember this thing, that it represents the upper bound. Okay, upper bound means it is used to represent the maximum complexity of the algorithm. Like over here, suppose my complexity is coming out to be n. Then what's the meaning of big O of n? Big O of n is saying that the maximum complexity of the algorithm is n. Maximum is n. So this graph is representing your n. And big O is saying that the complexity of this algorithm can't be in this area because this is the maximum one. This is the maximum complexity, but it may be lesser than that. That means it doesn't like this. It doesn't showing that the complexity is exact 10. What I'm saying, maximum is n. So it can be lesser than n. So it can be in this area, but it can't be in this area. It can't be more than n. That is the meaning of big O of n. Okay. Now, what's the difference between these two things now? Big O of n and n. Suppose if n is 10, now if you will tell me na, the complexity is just n, that means if n is 10, you are saying complexity of your algorithm is 10. That means it is performing a 10 operation. If n is 1000, that means you want to say your algorithm is performing exactly 1000 operation. And if it is 1 lakh, that means you are telling it is performing exactly 1 lakh operation. But when you're saying complexity big O of n, then what's the meaning of that? Its meaning is that when n is 10, that means maximum complexity, maximum number of operations performed by your algorithm would be 10. So whenever we are saying maximum is 10, that means it may be lesser than 10. हो सकता है कि आपका algorithm 8 operation perform करे, 7 भी कर ले, 6 भी करे, और हो सकता है 1 कर रहा हो उस time पे. But in all these cases, you can say complexity is your big O of n. And if it is 1000, even in this case, I want to say that maximum complexity 1000 hai, but it may be lesser than that. It may be 100, it may be 500, it may be 242, but it can't be more than 1000. Okay, so that is the difference between big O of n and n. So usually, I'm telling you from students' point of view, like if I will tell them, no, complexity is not n, it is big of n, they think that there is no much difference. But you can see there is a lot of difference whenever you are saying complexity is n or big of n. Okay. Value of fn is always lesser than cgn. Okay. So this graph is okay. What's the meaning of this graph? Okay. Now what I want to say, if you are having two functions, suppose you are having two functions fn and gn that is given to you, you will say that fn is big O of gn. How can you say? Or when you will say that fn is big O of gn, whenever value of fn is, here I have written value of fn is always lesser than equal to cgn. C is matlab I'm multiplying this gn with some constant value. Okay. So C means what? C means I'm multiplying this gn with some constant value for all n greater than n naught. That means before the value of n naught, value of fn may be greater, it may be smaller. यहाँ again greater हो गई है. But जब value of fn n की value है जो n naught से greater है, तो fn is always lesser than the cgn. When fn is coming out to be lesser than cgn, it is not greater than this, then you can say fn is big O of gn. Function f1 would be big O of gn if the value of fn is lesser than equal to cgn. You need to remember this thing. This thing is important. Why I'm saying fn is lesser than equal to cgn? Because I have told you that big O is always used to represent the upper bound. So over here, I'm saying upper bound is this one. That means the value of my function can't be greater than this. It will always be lesser than this. So if you're getting anything fn lesser than equal to cgn, then you can say fn is big O of gn, or you can write down like this, fn is big O of gn. Okay. Let me take one example, then it would be clear. Suppose over here, you're finding the complexity of an algorithm and the complexity is coming out to be 3n plus 2. Now you have to represent this in terms of big O. Okay. Now, how can you say that what is the big O of that? Okay, suppose you want to say that the big O, in terms of big O, it is big O of n. But how can you say that this is big O? You can say it is big O of something if 3n plus 2 is less than equal to multiplying this with some constant c into gn. Okay, now I want to find out what's the value of gn. Now here I have written, can I write down that 3n plus 2 is lesser than equal to 4n? That I want to say value of 3n plus 2 is lesser than equal to 4n for all n greater than equal to 2. Okay, put the value of n as 1 over here. If n is 1, this equation will become 5. 5 is lesser than equal to 4. Is it right? No, 5 is not less than equal to 4. But if you will put the value of n as 2, it would be 8 and it is also 8. 8 is lesser than equal to 8? Yes. Put the value of n as 3 now. It is 11 and it is 12. 11 is lesser than equal to 12? Yes. Okay, that means जब n की value 2 या 2 से greater है, then you can say 3n plus 2 is always lesser than equal to 4n. If it is lesser than equal to 4n, you can say this is your C value and this is your Gn. That means now I can say that 3n plus 2 is big O of what? Big O of n. Is it okay? That means the maximum complexity of my algorithm is n. It can't be more